Welcome back. In this fun math video, we are going to look at examples on what it means to combine multiple functions together. When we combine functions, essentially we're using order of operations, so we can add them, subtract them, multiply them, or divide them. Now, there's a couple hints that we need to make sure we remember when combining our functions. The first is when you're subtracting, you want to be sure that you put parentheses around your second function. And the reason for that is because you're going to have to distribute that negative sign through your second function. When we're multiplying, you want to make sure that you use parentheses around both functions. Most of the time you might be foiling or distributing one function into the other, and you need to make sure that you distribute the entire function. And last, when you divide, you need to make sure that whatever you do, your denominator is not 0, meaning your second function cannot equal 0. If it does, then obviously you can't divide them. So those are the little guidelines that you have to keep in mind when doing your operations with your functions. So essentially what's going to happen is you're going to be given functions, usually 2 of them, and then you're going to be told what to do with them. So in this case, you're given an f and a g, and here we're told that you want to add them, and this is evaluate at -1. And then we're told to divide them, and again evaluate at -1. So when we look at it, we've got a couple rules here that we're looking at. First is this part here tells you your directions, okay, or what we can call your operations. The second part here tells you how you want to evaluate. Okay? Now, sometimes that's going to be a variable, and sometimes it's going to be a number. It just kind of depends on what it is that you're being asked. So here we've got a -1. The first thing you have to do is your operation. So the first thing that we're going to look at is we are going to look at f plus g. So in doing that, my f is going to be 6 minus x all over 2, and we are going to add that to g, which is the square root of x over -4. Now, in looking at these, there's absolutely nothing that I can do to combine them, so I have successfully added them together. Now, the second part says we're going to evaluate. So here we're going to take our f plus g, and we're going to evaluate at x equals -1. So that means anywhere you have an x value, you have to put in a -1. So this is going to become 6 minus a -1 all over 2, and we're going to add that to the square root of -1 over -4. Once you've input your variables, now you have to simplify. So minus a negative becomes plus, so this ends up being 6 plus 1 over 2. And then here I have negative over negative, it becomes positive, so this is going to be the square root of 1 over 4. If we look at this first, 6 plus 1 is 7, so this is going to end up being 7 over 2. And then we have to evaluate this 1/4. So when you take the square root, remember your square root rules. You can break it into the square root of the top and the square root of the bottom. The square root of 1 is 1, square root of 4 is 2. So this is going to break down to being 1/2. When we combine that, Remember, adding fractions, you need a common denominator, which we do. And then you add across the top and keep your denominator. So this becomes 8 over 2, which again we can reduce to 4. So this is our first result. This is what f plus g equals. And then here we have f plus g evaluated at -1. And it equals 4. This is your second result. Now over here I want to divide them. So again, it's going to be the same thing. We're going to look at f divided by g. So my f was 6 minus x all over 2. And then we have to divide that. So I'm going to make my division bar a little bit bigger than my fraction bar. And then we need to put g on the bottom. So this is going to be the square root of x over -4. Again, there's really nothing that we can do here to simplify, so I would just go ahead and leave it alone for now. You could manipulate your fractions, but with this radical it becomes a little bit complicated, so I would just kind of leave it as is. The second thing we have to do is we have to do f divided by g and evaluate at -1. So to do that, we do the same thing that we just did, which is anywhere you have an x, we substitute -1, so this becomes 6 minus a -1 all over 2, and we're dividing that by the square root of -1 over -4. Now the beauty about this is because I'm evaluating by the exact same value, I've already done all the hard part because I already did all the math here. So what I know is I know that this top piece becomes 7/2 and this bottom part becomes 1/2. So I can simplify that. So this becomes 7/2 divided by 1/2. Your fraction rules say to keep the top and multiply by the reciprocal of the bottom. So that says that this is going to become 7/2 times 2 over 1. Your 2's are going to cancel, which is going to leave you with 7. So in this case, f over g evaluated at -1 is going to give you 7. And then just like before, this was your first piece. Alright, let's look at incorporating a domain. So not only can we combine them, but we can find domains of them. In other words, we can find everywhere that the current function you have is going to be true. So we have a couple things to keep in mind. First, f plus g, f minus g, and f times g will all have the exact same domain, and those domains occur where you have overlaps between the domain of f and the domain of g. For your division, remember, you're still looking at the overlap between f and g, but now we have to take into consideration that g cannot be 0, so it's going to change your domain ever so slightly. So let's go ahead and look at it. Here, I want you to find the formula and the domain for f plus g and f divided by g. So the first thing I have to do is I have to combine them together. So f plus g is going to be negative 2x squared plus the absolute value of x plus 4. Once you've done that, we can find your domains. And first we're going to look at your domain for f. So if we're looking at this, my f of x is 2x squared. So what do we know about my domain of f? Well, parabolas have domains of all real numbers. So that also means negative infinity to positive infinity. Well, not only that, but when we look at the domain for g, when we're talking about absolute value, we're also talking about all real numbers. Again, negative infinity to positive infinity. That being the case, when we're looking for the domain of a combined, your domain of f plus g is the overlap of your domain of f and your domain of g. Well, in this case, they're both the same, negative infinity to positive infinity, which means my domain for f plus g is going to be the same, all real numbers, which is negative infinity to positive infinity. Pretty simple. Well, now we need to do f divided by g. So when we set up f divided by g, what you're going to notice is that f is on top, so this is negative 2x squared. And now we're going to divide it by g, the absolute value of x plus 4. So when we're looking at this, my domain of f is going to stay the same. So now to find my domains, my domain of f is still all real numbers. But in this case, now my domain of g is going to change. And the reason for that is because now it cannot be 0. So here I have that the absolute value of x plus 4 cannot be 0. So here I know that when I have my x plus 4, it cannot be negative 4 because I cannot have a 0 inside my absolute value here. So now when I look at it, my overlap domain now has to exclude x minus 4. So my domain of f over g is still going to be the overlap, And so in this case, what we're looking at is we are looking at my domain of f over g to go from negative infinity to negative 4 union negative 4 to positive infinity. In other words, it is x such that x cannot be negative 4. Now, most of the times when we write domains, we use interval notation. Okay, so do make sure that you are usually using an interval notation when writing your domains. But that is your first look at how to accomplish your problem. Now, this is all we had to do. We didn't have to solve, we didn't have to simplify, we're just simply combining and finding their domains. Alright, let's look at another one just so that it sinks in. So again, we're going to look for f plus g. So f plus g is going to combine them, so this is going to be x squared minus 1 plus the square root of x is my x plus g. Now we need to find the domains. So to do that, I'm going to find the domain of f, which in this case, because it's a parabola, we are still going to have all real numbers, so negative infinity to positive infinity. My domain of g is going to be slightly different, and in this case, the rules of radical is that you cannot have a negative under the radical. So here this is going to be x is greater than or equal to 0. So when we look for the combined, so when we look for f plus g, again we're still talking about the overlap between f and g. So here, if we look at where they overlap, they're going to overlap everywhere that x is greater than or equal to 0. So your interval here is going to start at 0 and travel to positive infinity. Now the second part wants us to look at f divided by g. So in this case, f is still the same, x squared minus 1. But now we've got g on the bottom. So when we look at your domains, again, your domain of f is going to stay the same at all real numbers. So negative infinity to positive infinity. However, my domain of g is going to change ever so slightly. So first of all, I have to use my radical domain, which says that x has to be greater than or equal to 0. However, my new g also says that it cannot equal 0. So in this case, we have that x has to be greater than 0. Okay? So here, what you want to note is that x cannot be 0. Therefore, we have to change it. So in this case, when we're looking at f divided by g, we're still looking at the overlap. And so here, when we overlap, we are looking at everything that's going to be greater than 0. So we're looking still at x is greater than 0. So we have 0 to positive infinity. So that's a snapshot in looking at combining functions using your operations and then finding their domains. If you have any questions, please let me know. Otherwise, always remember to smile, have fun with your math, and I'll see you next time.